Okay, good afternoon or good evening, everybody. It's really a pleasure to be here in this seminar. It's a pleasure because I'm part of the organizing team, but actually it's the first seminar in which I'm participating in person. And I'm happy to see so many people in the room and so many people online. So I will just introduce the topic of today. We will discuss about a typical situation that we face when we work in context of international cooperation, actually in all fields, which is the scarcity of data, or the difficulty to find reliable data or the data we need for designing technical solutions, for proposing possible feasible projects. When we deal with the environment, this is particularly critical because maybe other types of data can be more easily found. And often the perception, once you start knowing a little bit this context, is that the data somehow are there, but they are maybe fragmented. Maybe they are hardly accessible. Maybe they're not free. Maybe the perception of how relevant the data are is not within the stakeholders you are working with. And there are, I think, many challenges and many critical issues. So we thought to devote one session of the ESIC webinars this year exactly about this topic. And we will focus not only on environmental issue, but even more specifically on water-related issues, which is one part of possible environmental projects. And we have two talks today. The first talk will be given by Professor Agustí Pérez-Foguet, whom I thank very much for accepting our invitation. I'll say just a few words, and then Agus, you can correct or integrate what I'm surely I will forget. Agustí Pérez, I think we met, I don't know, 15 years ago or more. And we start knowing each other. At the time, we were part of Ingegneria Sin Fronteras on Agustí side in Catalonia, Ingegneria Senza Frontiere here in Italy. And both we had a similar story of being part of this organization and then start working in the university, in the academic world, and let's say getting the importance, getting the feeling that it was important to introduce into teaching in the university and also into research the issues related, the cross-cutting issues related to international cooperation or the global dimension, as we named it in a joint project some years later. And Agustí works, I think he really started a novel research line, especially in the area of WASH, in water supply, sanitation and hygiene, and in working with environmental data or also social type of data, I think in the area of WASH. And probably, again, 14 years ago or so, I remember having a visit in Catalonia at UPC, at Politècnica of Catalunya, where Agustí is teaching. And he was starting these investigations, which then gave rise to a really impressive amount of research, very interesting and novel research in this field. And Agustí works with data analysis, statistical data analysis, but also modeling of environmental processes. And we asked him, from one side, we asked him speak of what you would like to speak about, but the topic is data scarcity in water-related project or environmental-related project. And the second talk will be given by 3 young researchers that who are working here in Trento, Marta Crivellaro, Livia Serrao, Nicola D'Alberton. Maybe you know them because they are also the team, part of the team who is setting up, managing this ESIC seminar webinar series. And we found that in their PhD project or research projects, which are different, there are 3 different ones, there are some common issues about data scarcity, environmental monitoring, and how to cope with that, and also in relation to knowledge transfer with local partners about environmental monitoring. So they combined a presentation together with 3 case studies trying to highlight the main challenges, the main open issues, and some results. Of course, it's also an opportunity to present what we are doing, something that we are doing here in Trento as a Unesco Chair in the area of research in context of environmental cooperation. So I'll stop here. I'm already lost. I already stole too much time. I'll give the floor to Agustí. Thank you, Agustí. Thank you very much.
Thank you, Guido, for the introduction. I assume that all of you hear me. If not, please tell me. Everything is okay? And now you should see the full screen. I can see the room with the people. Thank you.
Yes.
I don't know how to. No, perfect. Well, thanks to Guido, thanks to the University of Trento for hosting this chair and your work promoting engineering for human and sustainable development. And the title of our presentation is not very smart. It's quite simple, because at the end what I decided is that I had some examples that could be useful in the big title of water resource management in data scarcity context. Okay. In fact, I will start with an introduction. In this introduction, I will just put into context the idea of data for something and for what. And then I will move to the part 1 of the presentation. I will talk about water sanitation and hygiene monitoring, all the work, what we call the sector of WASH, all the infrastructure, service provider, and people that needs hygiene situations, sanitation services, water and water, the households, all this sector is not only about infrastructure, it's infrastructure, environmental, environment, and people. And in the second part, I will move to a more technical issue, but also it's a characteristic situation where you don't have a lot of data. It's the monitoring of the groundwater dynamic water level. When we are pumping of deep aquifers and we want to have an idea of what is happening with the water level inside the aquifer. And I will finish with some remarks. As Guido said many times, there's some data available, but it has not enough quality or quantity to be used for the goal that you could have. I focus first in the idea of we need to take decisions at local scale, think in a neighborhood, a community, a small city, so close to the people, and we could have some information or some data, but it don't have the quality or the quantity enough to do the analysis or the proposal or the decision. The first idea is to look for additional data. And the only thing to take care is that if we are sampling in reduced populations or we are trying to have some idea of rare events, we have to take care. It's not the same as sampling or looking for something that is the normal behavior. And we have also to take into account the additional cost that we will have to have additional data. Another idea is that usually there is data that could come from other administrative scales, so national, regional, that could be useful. And some statistical models could help. Well, we use statistical models to help decision making, and we can also use statistical models trying to see if some co-variables could help in order to infer what we need in order to make the decision. Well, in this kind of context, I will focus my first part of the presentation, and I will present, let's say, 2 things. The first thing is one work about sampling in small communities with some practical rules that I think that could be of interest. And the other issue also in this context is the downscaling of the national water and sanitation monitoring systems. So you could have some information, how to manage to see the information at the local scale, the idea of downscaling the information. We have other kind of problems or situations where we have also problems trying to have enough information, but in this case I will focus in physically based processes. In that processes, we usually have knowledge that can be used to infer the values of magnitude of interest if you give me another data, because we know some physical laws that relates the physics of that situation. So we have some data, and with something like the mass balance, we can have an equation, and then we have another information that could be of our interest. Think on all you know about physics, mechanics, thermomechanical issues, also the chemical reactions. There are a lot of laws and things that we know how to manage. In fact, we can see all of them as models that depend on parameters that links the inputs and the outputs. And typically in modeling, what we do is we adjust, we calibrate those parameters in order, with some data, in some specific and controlled context. And then we use that model to work in another situations. In fact, it's very common to model complex environmental processes to obtain magnitudes that in fact are difficult or too expensive to be directly measured. So in the second part of my presentation, I will introduce one example of this, and it's related to a work that I'm doing in the last couple of years. I start with that. It's the monitoring of pumping from deep aquifers, specifically in places where we don't have a lot of resources, economical resources, and we have interest in knowing the dynamic evolution of the water level inside the aquifer. Okay, so it's not for simple boreholes, but for special situations. Well, with respect to the first part, let me start just putting in context. The water sector needs local and segmented data, and for what? It's to connect the infrastructure with the service and the people. So it's not only a question of knowing the network of pipes and there is a firm that is providing water to the people, but if we want to know with more detail the situation, how is the people? Some people have more money, other people have less money, some people are vulnerable, other are not. Some neighborhoods have one infrastructure in one level of service, another one in another. If you think in developing countries, some of you are working there, the rural areas are very easy to visualize. You have the communities, some small infrastructure, some community service providers, some people going with self-provision by their own. We need to know more in order to decide what to invest and in which kind of activities and which kind of projects we should focus. Well, we have global, national, and even local data, and probably aggregated. This could be available, but usually this is not enough to inform what we want. In that context, I'm thinking in a small population dispersed, what happens usually is that quantitative analyses are not the main choice. Typically, the people realize that sampling is expensive, inaccurate, biased, so then we move to qualitative analysis, and that's good. I agree with that, I've done that, I'm happy with that. But if we can have some numbers, why don't we use that amount of numbers? And the problem is that it's not so easy, it was not straightforward. So what I'm going to present now is one work that we published some years ago, 3 years ago in Waterlines, just focusing in how to decide the amount of sampling that we need when we are in a context of reduced populations. And we use that to characterize and classify communities in Nicaragua and Mozambique. So I will move into it. You can find the paper in an open version with the contents. And basically that paper, here we have a summary, and I will start with this sentence. The standard approaches are usually expensive and time-consuming. If you just start with the basic of statistics and try to do it, you see that it has not much sense. So what we propose is some simplified linear approximations that helps an end user, not an expert in statistics, to propose a sample size given a precision of the results, a confidence level, and a population size, and some practical guidelines for household selection and transect walk planning when you want to do the survey in that community. Well, the key point is that usually we use a normal approximation to the distribution of the proportion that we want to know. And we'll focus on proportions. So we want to know how many yes and no there is for a certain question in a given community. In that big table, what you can see is big N means population size, which have small populations until not so small, and the limit for infinite populations where the normal approximation is good enough. And in the different columns, the sampling produced by the statistical formulas that tries to give us estimates with the desired precision and statistical significance of the confidence interval. What does it mean, a precision of 1/10? It means that if we have an estimate of 0.25, in fact, the width of the interval where we assume that, or we expect that will be the exact solution, will be between 15 and 35%. So D equal to 1/10 means a level of error that we are not used to work when we are in physical science, but we can manage this level of error if we are in social science and if we want to distinguish situations that are quite different between them. With this way of thinking, we can go further and we can increase the amount of error that we can accept, but it has a limit. The same happens with the statistical significance. If some of you are used to work with hypothesis tests, then you will identify quite easy the alpha value, the p-value that we use in when we make hypothesis tests. So a p-value and confidence interval for a 95%, alpha 0.05, it's in the limit of we are used. But we can take it a little bit further and talk about the confidence, statistical significance of 90%, so with an alpha of 0.1. The question is, are we able to do this kind of samplings? And these samplings with this kind of precision and significance are enough and could be implemented in practical terms? So what we proposed was a simple way of applying in practice these kind of formulas with these approximations, this linear in segments, taking into account that when we plan a survey plan, when we are planning a survey of different communities, we have to take into account the cost, time, people, how many teams, how many times for household. Then we need some reference numbers of the amount of household that we can do, for instance, 24 in 1 day or 2 days, when 1 or 2 teams. Then we want to pay for 24, for 36, for 48, which will be the precision and the statistical significance that we can reach for different sizes of the community. Well, this idea, we can go a little bit further in order to make it easy to be implemented. When you arrive at a community, if you want to do a sampling, a random sampling, you have to think how to do it. You need a list of the households, and then you need to select randomly some of them, not few, but most of them with these numbers, and then you have to look for them, make your questionnaire, catch up your information. There is another way of working that has some good points. We call it transect walk, if you imagine that you arrive at a community, you have more or less an idea of the amount of families, but you are not exactly sure of the amount of households. But what you can do is to make a path through the community, and then you will make the survey through, you cross through all the households of your community. In order to do that in a practical way, the idea is give to the team, of the working team, some rules of this kind. So, and this kind of rules should be written in the following way. You should select n household randomly from each group of big M households that you reach during your transect work. And in order to be random, what you can do is to prepare some patterns randomly selected. For instance, 5 or 7 means that you don't select the first, you select 3, then don't select the number 5, and then you select 2 more. This is random 5 over 7. This is another one. 6 over 9, you can elaborate different patterns. With these rules, it's not so strange, and it's possible to make some kind of quantitative analysis, although the amount of the community is quite reduced, the population is quite reduced. We did that, and we checked if these approaches were feasible and they give enough good results in practice, so in reality. So we have information of some villages with population ranging from 40 houses to 11 houses. The magnitude of interest with yes was 24 and 2. So the proportion is around 0.54 or 0.18. And what we want is to get that number with a desired precision. So we make a plan, and what we found is that the estimated proportions verify the precision requirements. So these plans and this way of working can give us good results. And it fails sometimes, but the error, the amount of times that it fails is below that 10% of the significant level that we ask for. So it's consistent, and it's a good way of working. Okay, and we use that for something or just to publish a paper? We use that. Here you can see an example that was, in fact, this example is 5 years before getting published, that paper that I show you. Just, we start working with that way. And here you can see some numbers. In Matagalpa, Nicaragua, some municipalities, some communities of that municipalities, the total number of households of that communities. And I remember that there the decision was, can we have disaggregated data at the level of community, or should we just think about municipalities? And we tried. We pulled this amount of household in each of the communities. We follow the statistics with care, and then we were able to compare the communities, because our goal was not to say if one or other community was exactly the same or not. Our goal was to differentiate or identify which community were failing in some of that categories. It doesn't matter the categories. It was availability, physical accessibility, affordability, quantity. But the key point here was not those numbers are equal or not. Probably they are equal. It doesn't matter. The important thing was Las Delicias fail in some of these indicators. So we need to get that difference numbers, and it's possible to do it with these kind of surveys. Same analysis was done also in Nicaragua. The same thesis was the thesis of Oscar Flores, and in that case we applied that idea to the case where some people in some households in the community are provided by self-provisions in different communities. In this example, one of them has 38. I expect that you can see my mouse. The community D has 38 houses with self-provision and 0 houses under community supply, but other communities have other combinations. So what we proposed was to stratify the sampling in two parts and then apply to the self-provision one small sampling and another small sampling to the houses that were under the service provider. The sampling was about 100 houses for 300 households living there. And if we didn't do it this stratified between self-provision and service provider, we should need 76, sorry. So it's not a big more. So it's big more, it's 25 more, but not so much. This kind of information is useful. Again, it's useful to see big differences. Here you can see the results in terms of the 5 normative dimensions of the human right to water, access to water, and we can see that the difference in the evaluation of the situation of the self-provision households with respect to the households that are under the scope of the service provider. And here we can confirm that the situation of self-provision is less good than the other houses in terms of a couple of the indicators, quality and acceptability. It's interesting because we saw in other communities the example around. I have another spider graph where you can see that the people with self-provision is able to have better level of services with one exception. They are not taking care of the quality. So they don't have a mark on quality, but they could if they pay by their own. So in any case, the important thing is splitting the survey gives us the possibility of differentiate situation of different subgroups. In the same line, another work, in this case from Ricard Ginet, we applied the idea of having not only an estimate of proportions. You can see here P sub I means the proportion of something in a list of communities, in this case of Mozambique. We usually rank the communities. And the key point is why Livgene will be rank 1 and Mytilene rank 2 if the proportion is so close that in fact are the same? Well, statistically, to say that something is the same that other things it's something that could be checked. And this could be checked quite straightforward, taking a look to the confidence intervals of the different estimates. This gives us an idea that was we can define some rules for categorize the different communities based on the overlapping of the estimates and the confidence intervals. And that was good because at the end we can give a final result in terms of blocks of communities and not only the number, because the numbers were so close and it's not really a different situation between them. Well, second part of the first part. I will follow with data, socio-environmental data. And now what I'm going to present is a work of a master thesis of Camila Vergara. I only have the slides and the information in Spanish, but I will just give an overview. And Camila made the master thesis working with a database with information of some countries in that time from Latin America, trying to see some methodologies that could help to understand what was relevant in order to understand the levels of service and the sustainability in the rural water supply and sanitation, in fact, in Latin America, in Nicaragua, in Panama, in Honduras. And she used the database that was being collected. Oh, not yet. First, let me introduce WASH a little bit more. That information of water sanitation and hygiene is structured following the typical hierarchical administrative structure of the countries. And the only specific issue to take into account is that we are taking care of infrastructure, of communities, and service provider and technical assistance provider, and they are not always the same. So you don't have always one community, one single infrastructure, one single service provider, one school, and one health center. Reality is more complex, and you have things that are interconnected. But at the end, you see the reality through the political administrative structure of that country. The other issue is that typically in the national information system, sectorial or general about the typical demographic survey and things like that, usually have census or microdata that could be useful at subnational level. Well, this is one issue. The other is how we make decisions at local level based on data. At the end, we make decisions based on some statistical models that are trying to give us support in order to make the decisions. No? And that models are typically adjust with the data defined at the geographical scale of interest. In the example that I have just showed you, I have been talking about communities, and we have seen the information of the communities. But sometimes that local level does not have enough accuracy, confidence, and we can try to use information from other geographical scales. This is that we call as downscaling. Take information from one scale and bring it to the other in order to work with a lower scale. Another example. The example was done using an information system that is called CSR. I have the web page, but I don't want to waste time there just because I want to be in time. So, but it's interesting because I went to the website this weekend again, and I saw that it was everything in English, Spanish, Portuguese, but also in Russian. And I thought that in the time that we are now, it's interesting to see that we can have a web page in different languages, including Russian. And this is because one country speaking Russian is inside this system. Okay, but in fact, this information system started in Honduras, Nicaragua, and Panama. That countries share during some years working teams in order to define a way of data gathering, data editing, data validation, define information queries. I could say more, having the same language and indicators in order to see how is the rural communities and how to invest and make decisions, okay? So the good point is that some countries share some information. So we have a good example in order to see how to take advantage of that information that could be in a country in order to see that local level. Oh, which is the proposal that you can find in this final degree thesis and this master thesis. This slide tries to say the following. We can see the data as inputs. We have a lot of data. That data could have just numbers or also categories of things, and will represent the amount of data that we have collected in all the community systems and infrastructure, whatever. Using some multivariate techniques as principal component analysis, factorial analysis in order to deal with variance of the data, or regression model discriminant analysis in order to work with some evaluation that we can have about the quality of the situation. With some of that techniques, we can process the data, and at the end we will have some models, and that models give us some outputs. Those outputs is what we use to build out some indices that will be used to support the decisions. Indices, the covariables, whatever. The point is that in order to have these outputs, we use some data. And we can use these techniques when we work at country scale. And then we'll have some results, we have some indices that are useful at country scale. But we can try to do that at subnational scale, some administrative unit, a department, a region. Then we'll have another data, and the results of the analysis will be another ones. And you can go down and go to a small municipality with 10 communities. And then you will have some data there. You can try to manage to build up some models and use it to inform decisions. But the point is that statistically, we have some criteria that will give us some measure of the quality of that models. And we can see, for instance, that at that level, this set of results is not of enough quality. Statistically, is not significant, or other measures. We cannot be confident of that. Instead of don't doing anything and don't use it, what we can do is use it from the bigger scale and inform what is happening here, taking into account that the overall behavior, in this case, of that model. Well, the idea is quite simple. In fact, this is the first step. Once you are able to do that, then you can imagine several ways of enriching the information and have some kind of LOAD A asterisk. The thesis stops here, and it applies that technique to different examples in order to see the usefulness of that. And this is an applied example. You can see here one place, Pirarea. Pirarea is a municipality inside Lempira. It has 20 communities. Lempira has 400 communities. Lempira is a department inside Honduras. Honduras has 3,500 communities. If we just focus in Pirarea with these kind of models, we can find some information. So we can say something, but only some things about exactly what is happening in Pirarea, but other things can be inherited from other scales. Some of the data that are well calibrated for Lempira will be used in order to inform Pirarea. And some of them, in this case, LOAD A and W asterisk AB, doesn't matter. These two will not be able from Lempira, but could be able from Honduras. Well, this was the second idea in the first part of the presentation, dealing with socio-environmental data. In the second part of the presentation, I will go to another kind of problems. And groundwater resource management gives us plenty of examples of problems with data scarcity. So you can imagine that usually we don't know the geometry of the aquifer, neither the boundaries. We have uncertainties about the flow and storage properties of soil and rocks, about the piezometric levels, the water level location in the boreholes. We can have seasonal or regional influences that we don't know. In fact, we can think that we know the pumping, but we usually know our pumping, but could be several pumpings in the same aquifer. Could be illegal pumpings there and we don't know about anything about them. We don't know that they are there. So in fact, it's not easy to know what is happening below Earth's surface. And if you think in deep boreholes, think about, now we will see an example of 100 meters, it's clear that it's not easy and we will not have so much data of what is happening there. In that situation, deep boreholes, there's sometimes we have the interest of understanding and knowing what is happening with the static and dynamic water level. And this could be of interest in terms of the pumping operation. You will have a modification of the water level could be of interest in the pumping operation. And at least it is of interest in general for qualifying the aquifer state, okay? There is equipment to do that. I'm not going to go into the detail, but there are several ways to trying to have that information, but it's not cheap. At least it's not cheap, okay? On the other hand, the water meters, depending on the country, can be mandatory. In fact, in Spain, it's mandatory. You have a pumping scheme with a borehole, you have a license to do that, but you have to install a water meter there. But it's not mandatory to have a digital one installed. It's manual ones. And the other issue is electricity. Typically, the boreholes, the deep boreholes, we have electrical pumping, and we record the electrical consumption, at least for billing, but usually not for control the pumping, because people usually only have some kind of on-off protection in the pumping. You don't want the pumping to be empty in the borehole or over intensity or problems with electricity, and you only have some kind of physical protection that makes you on-off, but you don't have the information of the electricity that you are consuming, that you are spending in order to pump the water in real time. So measuring water flow and pumping power, these two magnitudes, is much cheaper than doing the water level. And the key point is that we are able to say something about the water level just taking an idea of the data of the other two magnitudes. Why I have interest in these kind of problems? They are quite particular, but let's say what happened in this situation is that people don't do anything. I mean, if you have a borehole of 100 meters and you have problems with that, typically the farmers don't do anything. They are not able. It's out of their possibilities trying to measure what is happening and buy some new equipment, contract an engineer, trying to understand the results and things like that. And here you can see the following. Two screens, okay? In each of these screenshots, what you can see is for one day, 15th of December of 2020 or 16th of December of 2020, the evolution of two magnitudes. The water level in a specific borehole, ranging from starting at 84 meters below surface when we are not pumping, and after being pumping for during some hours, how the water level is going down until more than 100 meters below surface and go down. This is the blue line. The brown line is the water flow that we are pumping between around, let's say, 1 liter per second, 4 meters cubic per hour. And this is done with a system that is, the energy comes from a solar energy. We have a photovoltaic field, was partially cloudy the both days. And you can see with a precision of seconds how the water table moves and which is the flow that we are getting from the aquifer. Okay, and we were getting the data with a water meter with a pulsometer. It's not expensive. A Raspberry Pi with a hat that has an Arduino from one guy from UK, Le Chacal. This was enough to get information about the electricity consumption that is not here on the pictures, and a sonic water level meter that was the instrument that gives us the information of the water level evolution during this real-time operation of that borehole. Okay, we want to be able to predict the blue curve without the sonic water level meter, just with water flow and electricity. And you can see here the do-it-yourself equipment. The box has a soft starter for well, this is not do-it-yourself. This is an official equipment to manage a borehole with a soft starter. And the additional issues are the Raspberry Pi with the sensor, and you can see here how it's a sonic water level meter with the data acquisition that you should buy in order to get the data from that instrument from here, the Wi-Fi antenna. Okay. In that context, what we did is try to model. And in order to model, what we did is define a simplified context, confine the aquifer with a constant head pumping with a generator. So we will not be able to manage now a solar pumping. And in that situation, we can link the electric power consumption and the water flow, not instant water flow, but the water flow from the beginning of being pumping. And we can link both magnitudes with the water level now and in the future. We can build up a mathematical model for that. We can calibrate with measured data that give us which are the rules, which are the parameters of the aquifer and the pumping system. It could be done with manual or digital data. And then we can try to use that in real-time operations. So during measuring, we want to give an idea of where is the water level table. In order to do that, we make a further simplification. It doesn't matter now. We talk just about the average flow during the pumping time, and we have an expected value of the water level, but also a quality indicator, something that say me, I can trust that level or not, is not trustworthy. And if I cannot give trust to that level, it's not confidence, if a quality indicator says it's bad, then I should update the parameters. And this is not automatic, because at the end I need some qualified opinion from a human decision that says I prefer to say that this is what is happening. I have to change one parameter, okay? But I have an idea if something doesn't work. This is the key point that I want to highlight. Well, I will finish in short, just say you that here we have an example of, in the low left part of this slide, the electricity consumption, the water flow, the measure water level table evolution, and in the right part you can see a comparison between our modeling results with the results that we are getting with the sonic water meter instrument. And what we expect when we compare was some kind of agreement. And the agreement is quite clear, except I want to recall that the black line is not the model. The black line is the sonic water level meter. So when we realize that we're this kind of, let's say, small, they are less than half a meter, but these small perturbations put us in a trouble, because we were not sure if our model was best than the sonic water level meter, because we don't see the aquifer, so we were not sure what was the good solution. So the only solution for that was to make it manually and take a manual sonda, put it inside the borehole, and see with a manual sonda the level which one really was. So you can see that in fact these small errors are from the sonic water level meter. Here you can see another tracking for 12 days with some small pumpings, and these errors here are not large, are less than 1%, so it's okay. The sonic water level meter works fine, but the problem that we have is that the small errors these changes are too fast and too unpredictable, and it's not connected with the aquifer response. So this is not useful for real-time control. I cannot decide what to do with my pumping scheme if the information can change half a meter just because the sonda doesn't have this kind of behavior. No? The good point or the interesting point for me is that our model doesn't suffer of that. We didn't expect this kind of results, but it's what we find. So, final remarks. I explained you 3 things in 2 different fields. With respect to the first one, socio-technical systems, my remarks are: check the confidence, the accuracy of local decision support models, and if needed, use or update with information defined at larger administrative scale. Try to do this kind of downscaling of information. And don't forget, try to get additional data at a smaller administrative scale or subgroup of populations of interest. Okay. With respect to physical system, the remark is: consider the modeling of magnitude of interest based on other physical data that could be cheaper to obtain or more easily available. And be clear about the hypothesis and include some kind of uncertainty of the output of interest. Well, thank you for your attention, and we can discuss about these ideas later on. Thank you.
Very much, Agustí. I think it was very interesting to. I'm thinking. I don't know exactly all the background of all the audience, but I'm thinking of the engineering students, and I think I was thinking of 2 things. One is that I think you gave a nice perspective of how some type of data, which in our maybe imagination, which connect to the social dimension, can be analyzed in a rigorous way, and how statistics can help better informing the decision at local level. And I think this is a nice perspective. Unfortunately, I'm pretty sure that many of the students are thinking, well, I'm not sure I understood everything and all the details that you explained. Also because statistics is not so, I have to admit, so strong in our background. We are trying to improve it, but at least I hope for those who are not so familiar with the statistics and with the tools and techniques, that you gave the message that, of course, you can learn it and you can use it to make informed decision. And it looks complicated, but it's, I mean, of course, as every subject can be complicated, but learning the basics and starting with analysis is not so, is something that every one of you can afford. And so I'll now move on and give the floor, literally, to Livia, Marta, and Nicola, and I will let you manage the system here.
Okay. Yes.
Sorry, I just forgot, Agustí will plan to have then the question time in the end after the two talks.
Okay, okay.
Credo abbastanza. Devo vedere questo. Volevo togliere questo. No, vabbè, lo mettiamo sotto. Sì. Prendi alto. No. Adesso lo vediamo. Tac, meglio. Okay then. Good afternoon to everyone. I can somewhere the mask. I am Livia Serrao. I am a PhD student here at the department of the University of Trento, and with my colleagues Marta Crivellaro and Nicola D'Alberton, we are going to present to you some lessons learned and about the topic of the role of the university in addressing data scarcity context and challenges we are facing in environmental monitoring and technological sharing in water-related projects. So, okay, just to give you a brief introduction on the Unesco Chair, because we all belong to this institution here, which is held at this department. The Unesco Chair was established in 2011, so it's quite a long time here. Even most of you maybe doesn't know it. And what we are doing, we basically aim to contributing to the growth of a new generation of globally responsible and competent engineers, let's say more aware about the consequences and the social, environmental, and technological impact of technological solutions. So environmental sustainability is also a core topic in our investigation, and according to the Sustainable Development Goals, which are very fashionable in the last years, our main topics are about clean water and sanitation, as well as affordable and clean energy, sustainable cities and communities, climate action, life below the water, and life on land. But moving on, the main topic of today, we can say that the chair is now involved in 3 development cooperation projects concerning the environmental monitoring program. And as you can see from the map, we have the project of Alto Ayaga, based in Peru, where I'm involved. And then there is the Natura Albania in Albania, where Marta is involved. And then the Saving Water Growing Crops project where in Lebanon, in which Nicola is involved. Even though all these contexts are quite different, as you may imagine, there are different needs, there are different goals of the project themselves, but there is a common baseline issue, which is the lack of data, as already Professor Zolezzi told. So what we would like to do today and in the next future. We first of all found that there is a common need, let's say, for scientific research together with the involved stakeholders in international cooperation projects, which is the need of reliable and representative data to actually ensure the local development. So the change we want to achieve is a good representation of the target context, which means data collection and also the development of local skills to manage new data sets. And the target, the expected results we want to reach are some guidelines or toolkit that the university can use in the next future when involved in development cooperation projects. So where do we start? From what we know. And so we start to compare our different research projects to find a common line and start from that. So in a very briefly way, I'm going to show you more or less what I'm doing in Peru. I'm at the end of the PhD experience, so it means that we started in 2018. And the project, I mean, the main objective of the project is to enhance the resilience of baby banana producers in the upper Huallaga Basin, which is in the jungle part of Peru, against climate and environmental changes. And there are two main activities regarding the interaction between the active riverbed with the floodplain and the agriculture in the floodplain. And the second part concerns more the strategies of adaptation to climate change, which basically is the development of an early warning system for wind gas. And the project is promoted by Mandacaru, which is the fair trade company of Alto Mercato. I don't know if you heard about it. And is funded by the autonomous province of Trento. This is a photo of what happened when a wind gust meets a pseudo stem of a banana. So this is the problem of the context. And what we have done was installing 3 weather stations and all the tools needed to realize an early warning system, which means cloud server and IoT. And this is a map where the 2 of the 3 stations are located in Pendenzi and Chiringal, very close to Tingo Maria city. And this is the weather station of Chiringal. And this is more or less how an early warning system works. And it's not so difficult, but if you are interested in, we can discuss later. Now, again, I can give the floor to Nicola.
Hello. I will briefly introduce the project I'm working on. The project is settled in Lebanon, actually in the central part, among the biggest natural reserve in Lebanon, which is the Shuf Biosphere Reserve, in a mountain area. We shouldn't imagine deserts and so on, but like snow in winter and different environment. The name of the project is Saving Water Growing Crops. It's founded by the European Union, and the lead partner of the project is NGO settled in Milan, which is called the Istituto Oikos. What is the objective of the project? Is to work and face problems related to water scarcity and in a context of climate changing. And to address this objective, in particular, we are taking into consideration two solutions, technical solutions. One is an innovative solution, which is the precise automated irrigation system, which I will really briefly explain what it is. And the other one is the rehabilitation, is a really ancient technique, which is the rainwater harvesting solution. So again, dealing with data scarcity in my project, actually from this period, the main source of the data are basically farmers. So it's local knowledge, and how to collect this data was basically mostly interviews, questionnaires, and of course, local administration documents are present, but not really well organized. What will be installed during the project related to data collection is several IoT technologies, in particular soil humidity sensors, and weather station, water level meters. The idea is that all this information will be collected and provided in order to elaborate in cloud an irrigation advice, which may let's say, efficient the system, release the correct amount of water in the precise in correct timing, and reduce the losses. I will then leave the floor to Marta.
Okay, so shifting to the last. Natura Albania is the third project that the Unesco Chair is working on actively now. It's a 2 years project that is funded by the Italian Agency for Development Cooperation, Tirana headquarters, and it is implemented by 3 Italian NGOs that are working in Albania since years, that are BIS Albania, CESVI Albania, and CELIM Albania. And in this project, the University of Trento, along with other subjects like the University of Genova, is a technical consultant for some activities. But what's the objective? The main objective in this project is to capitalize and promote territorial and environmental framework in Albania, in particular to contribute to the sustainable development of the natural capital, strengthening the capacity of local institutions to work together and to manage and protect the natural capital of Albania. And in particular, universities' activities, so both University of Trento and University of Genova are focused in very detailed, I would say, and specific sub-activities. One is the hydromorphological monitoring of the Vjosa River corridor, in which we are involved as University of Trento. And the other is the modeling of the Nartas Vernes lagoon, that is a lagoon near the delta of the Vjosa River. So there is a geographical proximity of the two actions. And the starting point to create a synergy among these two actions is the fact that data in this situation are fragmented, missing, not accessible at all. So a synergy began among the two actions with the creation of a unique monitoring system. That it is composed of 2 hydrometric stations we built with the do-it-yourself solutions here at the university, with the collaboration of CISMA Consultancy, and also at the University of Genova. We installed them in Narta Lagoon for the University of Genova, and along the Vjosa River, in the upper part of the Vjosa River in Permette, some weeks ago, regarding University of Trento activity. And the further point with respect to actual monitoring system is that in Albania is the fact that these 2 stations are connected to an open access web portal where you can visualize and download the data. So This is a very rapid overview about the project we are working, and we would like to try to compare them, our experiences, what it has been to work on it on the technical side, and also on the networking and partnership side, and also which is the role we as university we faced in this project. We found some common aspects and some differences. And here you have the main common aspects. The first one is, as you may see, all the three projects are set in rural and low anthropized areas, where the natural environment has still a very relevant role for the socio-ecological balance of the system. The second aspect is that data scarcity at the beginning deeply influenced the reliability of the preliminary feasibility assessment. And this is quite relevant because it influenced a lot all the implementation phase of the project. And the third common aspect is that the three projects, they have all a wide partnership. And so this multiplies the efforts and the importance of the engagement of the entire partnership, all partners, and a specific role definition to better work together. About differences, as Livia already told you, these projects are set in different phases, and they have also different spatial scales. In fact, the project in Peru is almost finished, while the one in Lebanon and Albania are still ongoing under implementation. And moreover, there is quite a difference among the type of beneficiaries, because while for Peru and Lebanon, you have that beneficiaries are mainly farmers that are going to improve their production thanks to the early warning system and the irrigation devices and solutions. For Albania, we have also that institutions are going to benefit from the data that are given with the monitoring system. And another relevant difference is the goal with which data were created with our solution, because for Albania, the goal was from the beginning to have open access data, while this fact is still under consideration or came after in the other projects. So now the question is, will these monitoring technologies function on the long term? That it is the question we ask ourselves every day, I think. We found that there are some relevant keywords and aspects to consider when thinking about these solutions. The first one is networking. Networking is fundamental. It is fundamental to work with partners and stakeholders in all the phases of project cycle management in order to assure this long-term sustainability. The second is the relevance of the preliminary feasibility assessment that should be very deep and of course time-consuming, but fundamental to have an easier implementation and a more consistent project. And this aspect of the sustainability should be considered from the beginning, thinking already in the design phase how to manage it, which can be the solution to guarantee a long-term sustainability after project fundings will be over. Also the knowledge, both the knowledge in terms of transfer of knowledge, so to dialogue with partners, with stakeholders, but also the context-specific technological capacity are key pillars to be considered, because we should design solutions that are adequate and suitable to the context we are going to work in. And finally, monitoring and maintenance of the solution we provide should be integrated in project design and project implementation from the beginning.
Okay, so I will just quickly jump to the conclusions. So basically, we met. It's the first talk we had among our 3 different projects in cooperation. And the idea so far was to foster a positive process, which includes to emphasize the good aspects and try to maybe get connected to each other, trying to take one each other this, and try to not repeat the mistakes by others. So this is what we've been doing today. What could be the next steps is, first of all, try to expand the horizons. So with the idea of acquire further knowledge and try to probably network with other realities, with the idea to pass from single case scenarios, or let's say not many case of studies, to a general and broader perspective. And so one day, hopefully, we will reach the objective, which is to develop some guidelines and toolkits that may be used, and with the aim to for the university to get a new role in the cooperation projects, assuming a more lead and active role within the project. So the role of the university basically may create several outputs. On one side, guidelines for the university, and so, for instance, some methodologies may be replicable or suggested for future research project, master thesis, several stages in field. And on the other hand, some scientific outputs may go outside from the university and spread information and knowledge. So this is what we've been doing. I think it was a really fruitful moment of sharing, and already some solutions were coming. And I would like to thank you for your attention, with the wish that from this dryness of water and data, maybe like planting seeds, we can start a process of building a new forest. Thank you very much. Here are the contacts if you need. And here are some faces of the team of the Unesco Chair. And thank you very much.
Go to Zoom. Stop sharing. Okay. No, grazie. Okay, thank you. Or maybe I'll keep the other camera. Was the room. Okay, now it's time for questions to Agustí, Livia, Marta, and Nicola. Also from the first speaker to the second speakers and vice versa. So just open time.
Something to understand. I don't know if you...
Yes, can you hear, Agustí? Maybe you can hear. Yes. Just say.
Yeah. Introduce myself. Can you hear me, Agustí? Can you hear me? Yes. Okay.
Yes.
Yes.
Okay. Hi, I am a PhD student here in Trento. I'm working with machine learning in environmental modeling in a general perspective, let's say. I wanted to ask you, your research is very interesting. Thank you for the presentation, by the way. And I wanted to ask you, let's say a curiosity, because I didn't get if you explained, I don't think so. When you said that one of the objectives could be also to measure the uncertainty of the measurements.
Yeah.
Okay, sorry.
I have not understood.
Sorry.
Okay.
We are phasing.
I have not understood the question.
No, in fact, I didn't pose it. Yet.
Okay.
Okay, sorry. It was just the introduction. Yes, I wanted to ask you if you have any suggestion to measure the uncertainty, especially in the case where there is a lack of data, like you explained before, because I'm not expert in statistical procedure, like, for example, try to, how can I say, like you explained in the first step of your presentation when you said that we could, I don't know, tried with different distribution of data with permutation, let's say, or combination of data itself. When you have this type of lack of data, how can you measure uncertainty in your modeling or in your calibration? Is there a specific way, or do you know how to face it?
Okay, now I understand the question.
Okay.
In fact, I could say that I have prepared a slide for you. Well, no, I'm joking, but your question is pertinent, and the problem is that probably I answered that question some years ago in one way, and now I will answer the question in another way. I mean, I studied the typical courses of statistics, including multivariate statistics, when I studied the master's 25 years ago. So all the statistics that I learned is what we call the frequentist framework. So we understand probability basically in terms of flipping a coin. And in that way of understanding probability is where we build up all related with hypothesis tests, confidence intervals, p-values. We try to respond questions like, which is the uncertainty of one result, using one techniques. But these are not these are not the best techniques to respond that question. This is the key point. I didn't say anything finally in my presentation because it was not needed at that point. So we can talk about a lot of things, and only if your interest is exactly that one, quantify uncertainty, then it's better to move to a Bayesian approach to statistics. And the only thing that I want to say, because it's quite intuitive, is that first thing, before going further, you should learn the basics. So it's good to know how to manage in standard statistics before trying to go further. But going further, it's quite appealing because the idea is that we understand the probability as the uncertainty of knowledge about the reality. And the main goal of getting new data to building up models is to reduce our uncertainty thanks to the new data. And this could be done in this simple formula that says here, is that we understand that the posteriori probability of something could be written as the prior probability of this thing, something that happens before having data, without having data, something that we knew about that. For instance, tomorrow we'll see the sun if there are no clouds. We don't need to flip a coin to know that the earth is moving and we expect the sun to rise up tomorrow morning. This is a prior knowledge. And if we multiply the prior knowledge for the likelihood of a distribution given some data, we can have a posterior probability distribution about our knowledge of the reality. Well, this way of thinking has problems, some drawbacks, but has some good features. One of them is that it's more easy to include knowledge that is not directly in the data, and I would say, or in the physical laws. This is one issue. But the other one is the question that you raise up, is that the inference results that we make are expressed in terms of probability distribution of the parameters. So we can quantify in a more straightforward way the distribution of what we know, of the uncertainty of the reality. Well, I don't want to go into details, but I thought when you make the question that it's not only, if you focus the question in the way that you do it, you want to reduce the uncertainty that you have about one magnitude, you can collect data. If you want to merge that data with other data, with other knowledge that you have a priori, other issues, then you need a framework in order to merge that things, to put it together. And my recommendation is try with some simple examples of Bayesian statistics in order to see, for instance, how to update a probability of a binomial distribution, yes and no. And if you make that exercise, you will understand it because it's quite simple, and you will see the difference of thinking. And once you do that, then you can try to use it in your particular application. Being said that, another issue is this could be very practical and useful for you and for your practical application. But if you try to make conclusions based on that approach and you want to publish that in some scientific journal, you will need to explain it. So the people from statistics usually classify themselves as frequentist or Bayesian, and people is from one side or the other. And you have few people that have no problems on using the techniques of both sides in order to get the results. So, and probably that's why 20 years ago was not very usual to explain Bayesian statistics and Bayesian inference in engineering, because it was not the time, and it's computerly expensive except for simple models. Mm-hmm. But now, my opinion as a professor in a civil engineering school and master professor is that you should open your mind and, of course, know the basic of statistics from the classical theory, or as far as you can, because you can go very much far with that. But this other way of thinking is also useful. It's useful to learn at least the idea with some simple examples. And then you will be able to solve the question directly. I want to know the probability of that and the uncertainty. I want to know the distribution of probability of that parameter, of that thing. Okay, well,
yes.
It was not prepared. I mean, I don't know, but I was thinking on going further on that, and that's why I had the slide prepared.
Thank you so much. Thank you. There is someone else.
Thank you. Other questions? So this last question was actually contradicting my impression that people in the audience would not have understood. Actually, if everyone is like her, everyone has understood much more than I did, probably. Also online. Possono aprirsi il microfono. So also online, if you have any question, just open the mic and ask, or here in the room.
Guido, if nobody has a question, I can raise up one for the team of the University of Trento.
Yes, please.
When I hear when I hear your presentation and your, let's say, your worries at the end, or your goals and your planning, your strategic planning, something that I came to my mind is that in my university I try to propose the following, that I'm not sure if you are doing, but when we write research proposal, typically for the European Commission, together with the project, we have to present a data management plan. This way of thinking about data is something that we have to get, then we will take care of that, and we will use it for something, and it will be published. It will be published in a report, or it will be open, but not now, when we finish the project or whatever we decide. That management plan is very typical in research because data are in the basics of the research that we were going to do. So we make an agreement at the beginning about how we will use the data. And this is good if you are in a context of knowledge creation or knowledge transfer. And I want to connect this with another thing. In my experience, I've been 25 years trying to do several things. What happens is that you think that you will modify the reality, but at the end the reality goes in their own, and the reality modifies you. The question is, after 10 years or 15 years, which information will be available and for who? And my experience is that the scientific papers are there. I mean, something that could be a good goal is try to make applied research, as you has been showing to me, has been extremely interesting. The 3 case studies that you show just in a brief. But my point is, it's not just a question of Albania want it open now or tomorrow or no, the question is in 5 or 6 years, the wave will erase everything. Everything will be deleted. But not the scientific papers, not the PhD thesis. This will be in the repository of the universities. The papers will be in the journals. So, although sometimes the papers that came from applied research in international cooperation, sometimes they cannot reach the top journals, and you say, oh, it could be better to be in a lab and make another paper in a lab. The good point of doing cooperation related with data, with research, with knowledge transfer, and you should make a plan about data, but the good point is if you finish with a master's thesis, a PhD thesis, a paper in a journal, this information will be in a place that somebody will take care of that during years. Yeah. So it's something that if you are doing the work that I saw, I'm not sure about the impact, the real impact, changing the reality of tomorrow in Lebanon or in Huancayo or whatever, in Peru. But the data and the knowledge that you have generated there, you should take care that put it in a place that will be available for the future. And this is a commitment from the university. I mean, the private sector, even the public administration has not in the DNA taking care of the data. All the public data is subjected to political opinion. So it's very difficult to manage a real open data framework when you have countries and politicals in the middle. But it's our way of working in research, trying to put the data, do something, and if somebody can do it better or different, we'll use the same data. So I'm not sure if you have thought about that, because it's something related with your experience, the 3 experience, I think.
You want to make a comment?
Actually, I don't know how to correctly answer to your question, because I think that we all deal with this issue every day. And we also complained a bit about the issue of data scarcity and possibility to make the difference, because that's the reason why we are doing research in such context, I would say. But thanks for your consideration, because I think that it helps us on thinking wider. Because yes, the problem is that we maybe are focused on the very local problem, but thinking about the international research topic, yeah, maybe the scientific outputs will remain at least longer than the sensor, let's say. So yeah, I don't know if you want to add something on this, or.
Not to answer the question, but we can add something.
Yeah, sure.
Yeah, thank you very much for your observation. I completely agree, and I think, yeah, since this is an ongoing process, I think, yeah, of course, all the dialogues and all the input you could give us are really precious. So thank you very much. Of course, data assessment, previews, and publish results will be a central issue. No, I have only a consideration, not a question, because I think in cooperation often there are a lot of limits, both on in data collection, and so I think your panel was really interesting because I think it's like statistic and university and like, let's say, engineers with a broader approach may be really useful, because this is doing things in a clever way. Somehow I remember going to several, like doing more or less interviews to the farmers. It was really long time spending, and probably there are clever way to do so, both in terms of economic issues, which are often limiting the budget of the cooperation projects, and as well in the cost, for instance, of sensors. I think like we are working with pumps, for instance, in our project. So I found both your part of the discussion really interesting, because often, like, we should think in a different perspective, in a different angle, and maybe obtain data, not directly taking them, but in a clever way. And I think statistic is and should be probably a really good answer for many topics like this. That was a consideration. I don't know if you want to answer or add something, but thank you very much.
I only want to add that, in fact, in your examples, I found it very interesting because you are using some IoT devices in order to get information, blah, blah, blah. In fact, I'm now working with people in Peru, in Huancavelica, and they are working in the same kind of devices. So I work with the borehole, the thing that I presented with the borehole, I tried to work in Peru, and I realized that it was too advanced. It was too advanced for Peru because it's too advanced for Spain. So I don't have to go to Peru. I have the groundwater resource management in Spain. I see the reality here, and then I realized that even in a country like this, Spain, South Europe, where the knowledge is inside the university, inside the researchers, the transfer to the farmers, to the private sector, in order to improve how to work, is not in hands of much of the people. I mean, only few are getting in the top or in the limits. So with this, what I want to say is that if in our own developed countries, we are not able, that our rural communities, to work with the technology that we are defining and doing research, we should have a clear idea that in the middle of the forest of Peru will be extremely difficult, that it will be sustained in time. But probably this is not a problem. I mean, to be there during 3-4 years, working with people, with IoT devices, in order to show the possibilities of that technology in that reality, together with local universities and local, let's say, stakeholders, even if after 4 or 5 years it finishes and it dies, it will have impact. And my point was, if during that process you can do some kind of applied research, that information, that data will be also useful if there is another wave of transfer, of if that reality changes and then they want the information. So it's like, it's not good, it's not bad. For my opinion is it's not bad to be in some kind of realistic in terms of our possibility of changing the reality. But it doesn't it does not mean that we cannot do research at the border with low resources for problems that are the worries of the people, as those that you explained me. But it's just that, but your will could be higher than if everything goes in not a very good direction and 2-3 years it stops. It doesn't matter. You can find some steps and give some steps that would be useful also for others. So, well, it's just because I get the impression at the beginning that you were, let's say, the assessment was not good enough. Yeah, but never is good enough. I mean, at the end you have to start because if you don't start working, you are never prepared to have a perfect project with a perfect impact. So the good point is to start and to have a strategy in order to reach something from there. Yeah, nothing else. My research about boreholes cannot be applied in Peru because it's needed in Spain, and it's like closer to us. We have problems like Albania, but I can move through Spain and see problems similar to Albania and say, well, we can make transfer also here. Our public administration has not so much capacities as they usually say they have. I mean, so what? Just saying that.
When you were speaking, I was thinking about our public administration in Italy in some different fields or similar fields, and of course the level is quite similar. Is there any other comments? I think this debate is raising very interesting issues, also more in terms of how we conceive international cooperation.
First of all, I wanted to congratulate you because you are conducting very interesting researches, so very compliment to you. And secondly, I don't remember exactly if you are cooperating with university of the country also, or just with the local farmers and farms itself. No, also with universities sometimes. Yes, with some issues. Yes, I wanted to ask you if there are any problem also to communicate with the university themselves. Yes. And if yes, which problems? This is the first question. Another question is you spoke about low anthropized areas, and I'm not expert in these fields of data scarcity for these problems. So I wanted to ask you if you plan also to address these issues and these I don't know problem and application in high anthropized area. I don't know. I have in mind something like Bangladesh or India that have very high concerns in contamination in groundwater, something like that, for example. I don't know if there are some difficulties in conducting the research in high or low anthropized and why you chose these type of areas. And the other, I think, was, yes, about research that Nicola is conducting. If you are using, I think that in Emilia-Romagna maybe, but also in other regions, they are already conducting something like the intelligent irrigation, let's call it. And are you using the satellite data, or are you using something similar? Now I'll let you answer.
Okay. Very quickly about the relationship with the university from Peru. We started as a partners in 2018. Then there was, there were another dean, let's say, of the Faculty of Agronomy, and it changed during the project. And the new dean was against the former dean. So since the former dean approved and conducted the project, the new dean decided to cut off every,
I think this is one of the waves that Agustí was speaking about.
Yes. And so we can say that was more political issue than research issue.
Those countries openly
Yeah.
Have a contact with the university for this reason.
Yeah. That was the main problem. Then there were little ones, but yeah, we can discuss later on if you want. And concerning the topic of what are the differences between conducting research in a low anthropized area in comparison to a high anthropized area, I think that in a higher anthropized area, you can exploit, let's say, citizen science, which would improve your knowledge, because there are more people that can help you on collecting data by themselves. And so, yes, I would say that this could be one solution in that kind of area. No, I mean, the problem is that here in the University of Trento, we usually are contacted by people that are doing projects. So it means that, yeah, we can say that the project were already set in that kind of area, and the promoters decided to contact us and to collaborate with us, more or less. So, and that is one of the things that we would like to, not change, but enhance in the next future.
Yeah, and concerning the third question, well, first of all, let's say we're still on the tendering process, so we don't really already have like a proper network with the responsible of the smart irrigation. You were right. Yeah, I think in general, these systems works with some index, for instance, NDWI, and so forth. The issue may be that for our scale, since we're working on, let's say, 15, 20 hectares, the issue and the dimension of the grids may not provide so specific need related to the plant. So it may provide probably like qualitative and also quantitative, but not, let's say, I think in situ sensors at the moment will provide the most information related to the water. Yeah.
I'm sorry, I don't want to hold it, but I have the last question to you, please. Sorry, because I am not none of the It's an interesting, seriously very interesting question, because your projects are very different, and they wanted to ask if one of you want to say something, like you, Marta, that you didn't speak, and about the most difficulty that you found in your research, because if you would say one, well, which one would you say? Okay. Okay, thank you for your question, because I think this is the core of our everyday life, and I also discussed about it with Professor Zoretti some weeks ago in Albania, about the difficulty to cope from one side from the present urgencies linked to the project and the project impact that, for example, the donor is asking and the results. And on the other side, the research activities that is set in a project that has been built from other partners that were working in the context since years, that have not a lot of experience in working with university, maybe, or in integrating scientific research into international cooperation project. So sometimes it seems that they are quite different binaries that are going at different, and the train is going at different speeds. But I think that what Professor Pérez said today is quite the union. And so we are always worried about how to assure the knowledge about the data we are given to the project. And we never, personally, I never thought about the scientific research as the knowledge itself, and for the project. But this is, for me, this was the main difficulty in since now. Yeah, I don't know if Livia and Nicola would like to add something.
I totally agree with you.
Okay.
So thanks, everybody. I think we are running close to the end. If there is no more comment or question, everyone probably would like to go for a beer or for dinner. It would be great to have a beer together, Agustí, but in a while, hopefully.
Okay, I will take some coffee or tea.
Yeah. So thank you again very much for being with us and for your inputs. There is Marta. You want, yes, okay. And I think that we have some practical information, especially for the students who are attending the seminar in the end. So feel free to stay, Agustí, but it's just about the exams and so on. So if you prefer to leave, just feel free. We
Well,
just conclude.
Yes, I leave you if I can, and thank you very much for the invitation. Quite interesting your work around, and I am now working with people in Peru. So if there is option to work further together or is to be in connection, perfect from my side. And
Yes,
a pleasure
definitely.
also, Massimo. Okay, bye bye.
Same for us. Thank you, Agustí. Bye.
Bye bye.
So now I'll leave the floor to Marta with some more organizational practical issues for the ESIC webinars.
Okay, two things. Finally, the first one is that next week we have the 5th seminar that is about environmental conflicts, both in presence and of course remotely. So stay tuned. We will send the email with the speakers within the end of this week, possibly. And then the second thing that we received some emails about how to manage the examination and what is the topic and the format. The idea is to let you you are free to write on a certain topic we covered during the entire course of the seminars, taking advantage of the materials you can find in the online platform, and also the presentation of the speakers, but also further materials. If you want to do some research, you can do it, to try to describe the state of the art of a certain concern that is related to international cooperation and environmental sustainability, and to propose or describe the future challenges or propose a potential solution you found along the course of the seminar. So that was the main idea. I don't know if we would like to add something.
Just to integrate, so it's one CTS seminar. So the format is a short document, I think 1 or 2 pages. So just as Marta said, during the webinars, you pick up a topic that you learned about, which is some specific issue in environmental cooperation, environmental sustainability and international cooperation. So something that is inside this the broad theme of that we covered, and you just go a little bit in depth in it and write a couple of pages with your reflections and some hints that you took, combining maybe different material that you found during the webinars.
Also in the Unit 10 page of the seminar, you can find the details about the font and the format. And if you have some issues with the time of the sending of the work, you can write us and send it in advance. For example, for the Talete girls I saw in the room. So whenever you want, yeah, we would like to collect them within the end of June, possibly. If you need them, if you need the mark before, just send it to us and we will provide it. Okay. Okay, so I will remember next appointment next week about environmental conflicts at on 18th. And the last one will be on the 18th of May about nature-based solution in urban case studies. And that's all from our side, I will say. And so see you next week.
Thank you. Bye.